Hi everyone, welcome back to my channel. If you are new here, please do not forget to like, subscribe and share. So today's video I am going to explain a maximum product subarray in a lead code 152. This is also problem related to the array list. Let's understand the problem first. So you want to return the maximum product sum subarrays. If you take this array, so this is also subarray and this is also subarray and eventually this is also subarray. In this subarrays, you want to return the maximum product. So in the product, in the sense multiply of that subarrays. So if I take subarray as 3 minus 2 and 4, here the product will be in the minus term itself, right? So if you add 3 into 2, so it will give minus 6, and minus 6 into 4, it will give me the minus 10. So if I take one more subarray like 2 3, so this is subarray. If I multiply them, I will get the answer as 6. So if you check with any subarrays in this array, so this is a maximum in this example. Okay, I will explain how to solve this using an optimal approach. We will use a prefix and suffix techniques. Okay, let's solve the problem using an prefix and suffix technique. So before solving the prefix and suffix technique, let me explain why should we take prefix and suffix technique. So if you solve in a brute force technique, you will end up taking time complexity as a big O of n square and n cube. If you don't know about the big O of n cube and time complexity things and all, you can go watch in a Google or you Google it. It should be clear. Okay, and space complexity is always the constant. Okay, I am reducing this code to the time complexity big of n single pass. Okay, if you solve in a brute force technique, it would have taken more time to solve. So I'm taking only single pass by using a prefix and suffix technique. Okay, so how are you going to apply this prefix and suffix technique to finding out the maximum product subarray? So let me explain this simple four conditions. Then I will go to how we can able to solve in a prefix and suffix technique. So the possibility of an array. So they given some array. There might be a possibility that all arrays are positive. Okay. So all arrays are some positive integers. Okay. At that time, you do not want to take some actions. Right. If this is whole array itself a maximum product in my case, if I take one more condition, if it is even negative in the sense both signs are at the even, like 2 here 2 are negative, might 4 be negative or 6 be negative, like that. Okay, if you take like that, for example, this is an perfect array for even negative because we do have a 2 negative. If there is a 4 negative, you call it as a even negative. So in this example, they given minus 1 0 and minus 2. Okay, if you multiply this, I will get in a positive answer, right? So this is also my maximum subarray, you can able to tell like that. But in the array, the 0 is maximum because negative number is which is minimum, then the 0. Okay, I cleared about two conditions. Let me go to the third condition. If I see carefully about the third conditions, which is odd negative, might be one negative or three negative in the array. So this is a perfect example for that. So if I take this array, like I have a positive and positive integer, and I have only one negative, which is an odd negative, you can able to say it like that. So if you have an odd negative, if you calculate here, I will get a negative some value, right? Suppose value is x, I will getting the negative value. If I add this 2, I get the positive. Okay. If I add this subarray, I will get negative. If I add this whole, I will get negative, right? So this is what we want to think of. This is what we want to think of and apply to our problem. So at the last, you end up taking some, if it has a 0, uh, for this condition it is okay. But if they given like positive 2, 3, here 0 and some value like 4 and 5, so again 0. If they given like this condition, if you add a product like this, it will give me the 6. If I add this, it will end up taking 0, right? And if you keep on adding, the answer will be 0. So for this condition, we want to think and write the conditions. Okay. So let's understand the prefix and suffix technique. So let's understand the prefix and suffix technique. So let me take some example before going to the actual problem. So if I take some array like this, okay. If I take some array like this, from this part I'm going to calculate. I will take it as prefix as for now. If I traverse, here I will get the maximum as 6. Here I will get negative minus 6. So here I want to handle this case. And if I somehow handle this 2 case and calculate this part, can I, my problem is done solving that 2 cases, right? I can able to say if you handle these 2 cases, I done with my problem. So if I take one more variable from end, okay, I will name it as suffix. If I traverse backwards, here if I get this maximum, you can able to say 5 4s are 20. So if I calculate like this from forward and backward, my question will automatically solved by this prefix and suffix sum. So you just want to handle this negative, or it can be handled by importing the maximum function. 0 you want to handle. If prefix will become 0, you will convert it to 1, so that you can able to calculate for a 4 and for the 5 also, like that. If you do not given any 4 like this, for this example, for prefix it going to be the year 6 and years minus 6. So here also minus 20 something. 6 4s are 24, sorry, my bad. Minus 24. So minus 24 is not my answer, right? If I given some like this array, it would have taken into 5. So something value which is in negative. Okay. If I traverse from backside also, this is suffix. If I traverse from backside also, like it would give me the answer as 20. It would give me my answer as 20. Here again the negative will be carried, right? Negative value will be carried. But here I am getting the answer. From here I am getting the maximum. So I think my display has get messier, but you understand what I said, right? So this is how you implement. Let's solve these 2 examples using my trick. So let's recap what I explained in a previous example. So if you take a prefix variable at the starting, if you calculate the product. So from here, let's suppose this positive integers. So this is positive sign I am taken. So this is some integers which is positive. I taking negative here. So this is some negative integer. So from onwards there is a positive integer. So if you calculate product from up to here, the my answer will be positive. From here, my answer will go negative, right? So I want to handle this positive. It because this is also a subarray part, right? So I taken one more variable. I am traversing backward. So if you calculate from here, my product will be positive. Onwards negative, it will be negative. So I somehow handle the negative right here. Just I want to think of 0. If it is 0, just convert it to 1. Okay, like that. So if you understand this problem, let's apply to this example. So yeah, prefix and suffix products we are calculating. So prefix and suffix will be initialized to 1. So I'm going to track it. So here prefix will be there. So I will just traverse the prefix first and then I'm going to do the suffix. Okay. So product will be 1 into 2. It is going to be 2. So I taking one more variable as max. Okay. Sorry to me, I did not return. So max I am taking. So comparing about maximum, I am storing in the max. So 2 is max for now. I store as 2. And I'm going to move the pointer to next element, which is 3. So 2 into 3, it is going to be 6. So 6 is my maximum, so I'm going to store that and I'm going to move it. So now my answer will be at the negative part, minus 12. So this is not my maximum. Compared to both of the element, my maximum itself a maximum, so do not store the negative. So move on to the next element, which is minus 24. So this is also not my maximum. So the prefix sum will be ending here. So let's calculate from suffix. So suffix will be added 4 first. Sorry, multiplied 4 first. Next it is going to multiply the minus 2. Minus 8 will be my answer. So this is not maximum. So move to the next. So as for now, all will go negative, right? So I don't need to calculate, but now I am calculating. Minus 8 into 3, minus 24. So this is not my answer. Then it's going to multiply with the 2, minus 42. So this is also not my answer. So you somehow handle the negative cases. So here my loop will end to the suffix also. Then I'm going to return the maximum, which is 6 is my answer. Okay. Let's move on to this problem. So they given minus 2, 0, minus 1. So this example is completed. I'm solving this problem. So the prefix will be 1 and suffix also initialized to 1. So minus I'm going to initialize to minus infinite probably. So minus 2 will be multiplied with the prefix. So it's going to be minus 2. So as for now, minus 2 is my maximum. So update and make it as minus 2. And compare with next element is going to be 0. So as for now 0 is greater than the minus 2. So update and make it max as a 0 and move to next. Before moving to next, if it is prefix is 0, you want to convert the prefix to 1. Important step for handling 0. Okay, then you're going to do minus 1. You probably get minus 1. So 0 is greater than the minus 1, right? So you stop here. Prefix is completed. Now I am going to backward traversal. So multiply with minus 1. It is 0 is my maximum. So move to next. So it's going to be 0. Again, it's same thing. You don't want to update. Before going to moving to the next element, you want to change suffix to 1, because if you carry out the 0, my entire left part will be 0. For that reason, you convert suffix. If it is 0, convert it to a 1. Okay, then you want to move the pointer to next, which is -2. Probably it is smaller than the 0, so keep maximum as it is, and it ends the after completing the prefix and suffix iterations, you will get the answer. So let's code this in a lead code. So I'm in the lead code problem 152, which is a maximum product subarray. Given an array nums, find out the subarray that has a largest product and return the product. So the test cases are generated so that the answer will be fit in a 32-bit integer. So I already explained these examples. So get it to the problem. So I'm going to take two variable, which is prefix. I will initialize to the 1, and I'm going to take one more variable for the backward traversal, which is a suffix. I'm going to initialize that also to the 1. So I'm going to find out the length of the array using an array dot length. This is going to give me the length of the array. Then I'm going to probably take it max. So this is going to store my largest product. Okay, and I am going to initialize that to the integer mini. Okay, sorry, integer dot min value. So this is the minus infinity, what you call. This is minus infinity. Okay, so I'm going to traverse. So rather than writing for prefix different code and the suffix different code, I will write it in a single pass by like this. Okay, I want to add the prefix multiplication. I want to do multiplication by initializing like this. So that array I'm going to calculate. So also I will calculate suffix here also, like doing like this. Okay, I want to multiply with suffix 2. Can I write this as an n minus I minus 1? Yeah, this is going to give me the last integer if it index is 0. Okay, if index is 1, it's going to give me the last second element. So one more case, I want to add, initialize maximum. So I probably using the built-in function max function. Max function. I want to calculate with max itself, and I want to calculate with the prefix and suffix sum. Right? If I'm going to take a prefix and a suffix, among them which are maximum, and among them which is maximum, they're going to give me the answer. Right? So one more case I want to handle, because if it is 0, I want to make sure it should be converted into 1 before going to the next element. Okay, and one more case, if it is suffix is also 0, for that also you probably converting it to a, you are converting it to a 1. Okay, this is a perfect code. So at the end, I'm going to return the maxi value. So let's run this. Yeah, probably I make some mistakes. So let's correct it and run. Okay. So I given wrong number. Sorry, wrong syntax. So yeah, accepted. Let's sum it up. So the time complexity is big of n, and space complexity is big of 1. So this is how you're going to solve this problem. If you like this video, do not forget to like and subscribe and share. So that's all for today, guys. Thank you.